Okay, so I'm going to go through the transistor lesson that I did this week. It's for people who missed the lesson, but also you might want to just go back through it and have a look to remind yourself what we've been doing. This is the circuit we've been looking at. It's called a switching circuit. It's got uses a transistor here, and we're switching on and off a buzzer. We're doing that dependent on whether it's light or dark. So we've got down here a light dependent resistor. Now if you look, I've got two circuits here, same circuit, but in this circuit I've got the light missing the light dependent resistor, so this is in the dark, and when it's in the dark the buzzer is on. In this circuit here the light is hitting the light dependent resistor and the buzzer is off. You can see that the thing that changes in the circuit is that when there's no light hitting the light dependent resistor, it's got a really high resistance. When there is light hitting the light dependent resistor, it's got a really low resistance. And what that does is it changes the voltage here. And when the voltage is greater than 0.7, the buzzer goes on. When it's less than 0.7, the buzzer goes off. Now you can look back through the other videos, and you can look back through the notes on potential dividers and switching circuits to find out how that happens. But what we need to look at are 4 specific circuits. So we're going to look at this circuit first of all. Now you need to know all these circuits. This is something called a dark sensing circuit. So you can see on here when the light is off the light dependent resistor, so when it's dark the buzzer comes on. I can also change the light dependent resistor for a thermistor. So you can see as the temperature drops, the buzzer comes on, and we call this a cold sensing circuit. So it senses that the temperature has dropped. Now what we need to do is we need to be able to make a circuit to work the other way around. So we need to be able to make a circuit that works detecting when it gets lighter or detecting when it gets hotter. So what we do is we swap around these components. So these two components here, we just change them round in the circuit. So you can see on this one I've got the light dependent resistor at the top now, and when the light is shining on the light dependent resistor the buzzer is on, as compared to this circuit here where the buzzer's on when it's in the dark. I've also got this circuit here, this is my thermistor. I've swapped those two around, and you can see that this has gone on when the temperature increases. So we call this a dark sensing circuit. We call this one a light sensing circuit. This one here at the bottom would be a cold sensing circuit, and this one here would be a heat sensing circuit. Now it's not exactly true, because what this is doing is it's sensing that it's getting darker and switching something on, and this is sensing that it's getting lighter and switching something on. This is sensing that it's getting colder, and this is sensing that it's getting hotter. So they're not set at specific temperatures or light levels. Okay, so you need to remember all these circuits, and the only way to do that is to remember the basic circuits, and then I'm going to give you a little tip on how you remember where the components go in each circuit. So first thing that you can think about this as a light level. When the light level gets less, when it's getting darker, I put this light sensor at the bottom. When the light level gets higher, so when the light level gets more or higher, I put the light sensor higher in the circuit. That's the way that I remember it. So when I want to detect that the light level is getting lower, I put the light sensor down low in the circuit. When I want to sense that the light level is getting higher, I put the light sensor higher in the circuit. I can do the same with the temperature sensor. So when I want to sense that the temperature is getting lower, I put the temperature sensor lower down in the circuit. When I want to sense that the temperature is getting higher, I put the temperature sensor higher up in the circuit. Okay, so this is the circuit that I'm going to look at now. This is a circuit with a thermistor in, and it's down at the bottom. So it's going to be sensing when this temperature drops. If you look here, I've got a high temperature there, 40 degrees centigrade, and the buzzer is off. I've got a low temperature here, and the buzzer is on. So that's quite a useful circuit. It shows that it works the way that I thought it would, but I don't exactly know what temperature it's switching on or off at. So what I've done is a bit of trial and error. I messed about with the temperature on this circuit, and I found that just under 30 degrees the buzzer is on, and just above 30 degrees the buzzer is off. Now that's great. If I want my circuit to work at 30 degrees, that's good, but I'm going to want this circuit to work at different temperatures. I'm not always going to want to detect at 30 degrees, so I need to find a way of adjusting the temperature that this circuit will work at. So what I could do is, it seems the most obvious thing to do would be to change the thermistor, change the temperature sensor, but that's not very viable, because they only make a few different temperature sensors, and they work within a certain range, but they make hundreds and thousands of different types of resistors, and all I'm trying to do is change the voltage at this point here so that it goes to above 0.7. Now I'm doing that by dividing the voltage up here, so dividing this 5 volts up, and I want it to be 0.7 or above here when this goes on. So rather than change this resistor at the bottom, I could change the resistor at the top. So you can see here, at 20 degrees centigrade, this is on with a 20 kilo ohm resistor up there. At 20 degrees, so exactly the same circuit, same temperature, with a 30 kilo ohm resistor, my buzzer is off. So that's one way that I could do this. I could vary the resistor. Now, a bit of trial and error, I found out that with 30k on, it switches on and off at 15 degrees. But this is a pain. It means if I want to adjust the temperature, I've got to unsolder a resistor, put another resistor in, or use a breadboard, and do that by trial and error. I could use Ohm's law to work it out, and we will do that in the future, but I'm going to show you how you can do it practically quite easily. And what we could do is we can replace this solid resistor up here, so just a standard resistor, with a variable resistor. So if I make this a variable resistor, this one goes from 50k up here down to about 1k down there. I can change the resistance on this easily and get this buzzer to switch on and off at the temperature I want it to. So the way that I would do that is I would put the thermistor into a situation or into a temperature where I want the circuit to switch on and off. So what I could do is put it in a heat controlled oven, or I could put it in a fridge or a freezer depending what temperature I want. But the easiest way to do this is put this into a waterproof bag, put it into some water in a beaker with a thermometer, heat that up till I've got exactly the right temperature, and then adjust this resistor until the buzzer just comes on. So I can see here it came on when the resistance was 22.21 kilo ohms, and then I can lock that resistor there. I don't need to move it again, and it will always switch on and off at 20 degrees centigrade. Then if I wanted to change this down to 0 degrees centigrade, I could just unlock this, move it to another point here where this switches on at 0 degrees, and then lock it in place again. Okay, next up we looked at what we were going to do next. So there are two things here that we're going to look at next up after the switching, well, as part of the switching circuits. The first one is comparators. Comparators basically are an integrated circuit version of the circuit we've just been looking at. They take a maybe a temperature or a light level, so say 20 degrees or something like this, and they use that as a standard, a base, and they compare a variable signal, so it could be from like a thermistor or something, against it. And what they do is when the variable signal goes above the fixed signal, it switches something on, and when it falls below it, it switches something off. So it works in the same kind of way as the switching circuits. Now we'll look at that in more detail when we've finished the switching circuits. But the next thing we're going to look at are MOSFETs. This circuit here is a transistor circuit. This is an NPN transistor that we've been looking at. And in theory, it switches this load on and off. But in practice, what actually happens is it starts to switch the circuit on at 0.7. But it doesn't switch it on fully. It actually has this linear region here where it switches between on and off, and it's got quite a long, so that's over 1 volt difference between on and off there. So what it means is that rather than switching something on and off instantly, it's got a bit of variation. If we look at this component here, this is called a MOSFET. So you need to know this symbol, and you need to learn it. You need to learn the 3 connections to it as well. But we can look at this, and this is our NPN transistor, and we know that it's got quite a long, or quite a big section between switching on and off. So this is a bit like using a dimmer switch to switch on a light source. I can turn it and the light gets lighter and lighter until it's fully on. A MOSFET has got a much smaller linear region, this bit here. So it pretty much switches on and off instantly. So that's like using a flick switch, so a light switch. So that's all you need to remember at the moment. We're going to look at how we use these two in the same circuit but for different applications a little bit later. Okay, so I hope that helps with the lesson. You can watch this again if you need to, and you can contact me. I'll put this up on the Teams chat and it's on YouTube as well, so you can access it when you need to.